Welcome to the Code Navigators. We're your guides, helping you navigate the sometimes complex world of the International Code Council books.
Yeah, we know getting into these manuals can be tough. Whether you're studying for an exam or, working on a project, pulling out what you really need from all those rules takes effort.
And that's what we're here for. We'll walk through key chapters of the ICC codes, explain what's in them section by section, and show you efficient ways to find the info you need.
It's not just about memorizing what the code says. We want you to understand the why behind it, how it all fits together as a system.
Right. And just a quick note on how we put this together. We use AI assistants to help generate the content, but it's all produced and overseen by a human code professional.
We aim for the best clarity and accuracy based on the source material we're examining for you.
Okay, before we dive in, we have that essential legal disclaimer. Please remember, this is for educational purposes only. It's meant to help you understand the code structure and general content.
Yes, let's be really clear on this. This isn't professional advice. It's not a code interpretation, and it definitely doesn't replace official code enforcement decisions.
You always need to consult the official current code edition that your specific jurisdiction has adopted.
And hire a qualified professional, like an engineer or architect, for your specific projects or any legal applications. Think of us as guides to the text itself, not interpreters or lawyers.
Exactly. So with that important point covered, let's get into today's topic. The 2021 International Building Code, and specifically Chapter 8, which deals with interior finishes.
Chapter 8. Yeah, this one's critical for life safety. It's all about the initial stuff of fire encounters inside a building, what you can touch, see, walk on.
The first fuel load.
Precisely. Its main job, as the user notes point out, isn't about stopping structural collapse. That's more Chapter 7 territory. Chapter 8 is focused on controlling how fast the fire grows and how much smoke spreads, especially in those crucial first minutes.
That's a really important distinction, isn't it? Chapter 7 is the long game, fighting the fire over hours, maybe. But Chapter 8 is about that initial phase, giving people time to get out safely.
Exactly. It regulates the finishes and decorative materials based on how they're used, what kind of building it is, the occupancy, and the fire hazard they represent.
So if the paint or paneling on the wall burns too quickly,
it can overwhelm the building's initial defenses and drastically cut down that escape time.
Okay, so we're covering wall finishes, ceiling finishes, floor finishes, and also things like curtains, banners, the decorative stuff.
Right. And the rules lean heavily on fire tests, specific standards that measure fire spread and flame propagation. That's where we get those A, B, and C classifications you see everywhere in this chapter.
All right, let's start digging into the chapter, beginning with sections 801 and 802, the scope and general requirements.
Okay. Section 801, the scope, is pretty simple. 801.1 just says this chapter covers materials used as interior finishes, trim, and decorative materials. It basically draws the line around what we're talking about.
But you mentioned the user notes earlier. They kind of set the philosophy right, that the acceptable fire spread depends on the risk of the occupancy.
That's the absolute core idea. It's the foundation. Think about it, a hospital, which is Group I2 versus maybe an office building, Group B. The requirements for the hospital finishes will be way stricter.
Because people might not be able to evacuate easily.
Exactly. Non-ambulatory patients, maybe slower detection, complex evacuation plans. The finishes have to slow the fire down as much as possible. In that Group B office, people are generally awake, mobile. The code allows a slightly lower standard, but still controlled, of course.
Okay, that makes sense. And this leads us into Section 802, general application. You said this is like an index?
Pretty much. 802.1 and 802.2 are key pointers. They tell you wall and ceiling finishes need to follow Section 803.
And floor finishes.
They need to follow Section 804. And really importantly, both sections emphasize that the requirements depend on that occupancy classification. It constantly points you towards needing to know the occupancy first, and often towards Table 803.13, which we'll definitely get into later.
What about 802.3, decorative materials and trim?
Right, things like draperies, banners, stuff not permanently stuck to the building. They're handled separately in Section 806.
Why separately?
Because they pose a different kind of risk. They're often lighter, maybe more flammable, and can spread fire quickly across a surface, even if the wall behind them is rated. You have to treat permanent finishes and temporary decor differently.
Section 802 also seems to cover some specific situations or cross-references.
Yes, it clarifies things, like 802.4 points you to Section 1612.3 for buildings in flood hazard areas. Finishes below the flood level need to be flood damage resistant. Makes sense, right? Durability matters too.
And 802.5 is interesting. It confirms that combustible materials can be used.
Absolutely key point. This isn't the non-combustible materials only chapter. It's more like the controlled combustion chapter. We're managing how fast things like wood, vinyl, or fabrics spread flame, not banning them outright.
So we can have wood paneling as long as it meets the right class.
Exactly, provided it meets the requirements laid out later in the chapter, usually in section 803 or 804.
Then 802.6 gives a pass to wood or unprotected metal window frames in exterior walls.
Yeah, that's just recognizing that exterior walls have their own set of rules, mainly about protecting from fire outside the building. Chapter 8 doesn't need to pile on restrictions for the window materials themselves in that context.
Okay, now 802.7. Foam plastics. These always seem to have special rules.
They absolutely do. Foam plastics, think rigid insulation, some decorative moldings, they're a big concern. When they burn, they can release a lot of heat very quickly, plus dense, often toxic smoke.
And they melt and drip, right.
That too, creating another hazard. Because they're so flammable and release energy so fast, the code explicitly says they are not treated like regular interior finishes.
So where did they get handled?
Section 802.7 sends you directly over to Chapter 26, specifically sections 2603.9 and 2606.5. That path almost always leads to requiring a thermal barrier.
What's a thermal barrier typically?
Usually it's a layer of gypsum wallboard, minimum ½ inch thick, placed between the foam plastic and the inside of the room.
To delay the foam getting involved in the fire?
Precisely, to keep it protected. The only real exception is for very, very thin plastic sheeting or vinyl covering applied directly over the foam. This cross-reference really shows how cautious the code is about materials that can cause a fire to escalate rapidly.
So Section 802 sets the stage, defines the material categories, points us to the main sections like 803 and 804, and handles these special cases like flood zones and foam plastics.
Because our roadmap for the rest of the chapter.
All right, let's get into Section 803. This feels like the real meat of Chapter 8, covering wall and ceiling finishes. You mentioned testing is key here.
Absolutely. The whole classification system hinges on testing. There are primarily two paths. The big one is NFPA 286, the room corner test. The alternative is ASTM E84 or UL 723, the Steiner tunnel test.
Let's start with NFPA 286, Section 803.1.1. You called it the gold standard.
Yeah, because it's a full-scale test. They literally build a room, install the finished material as it would be in a real building, and start a fire in the corner. It measures how that material contributes to the fire's growth in a realistic setting. It's about actual performance.
And 803.1.1 lists 5 very specific things a material has to achieve to pass this test.
Right. These 5 criteria basically define what makes an interior finish acceptable when tested this way. 1, no flame spread to the ceiling during the initial smaller fire exposure that's 40 kilowatts.
Okay.
Controls the fire early on.
Yeah.
2, the flame spread can't reach the outer edges of the sample, either on the walls or the ceiling, during the whole test. The material itself shouldn't become a pathway for fire.
Makes sense.
3, and this is critical, flashover cannot occur. We should probably unpack what flashover means.
Definitely. Point 4.
4, the peak rate of heat release can't go over 300 kilowatts.
It's 5.
5, the total amount of smoke released can't exceed 1,000 square meters.
Okay. Let's go back to number 3. Flashover. We hear that term a lot. What is it exactly, and why is preventing it so central to this test?
Flashover is the transition point. It's when a fire stops being localized, just burning in one area, and certainly involves basically everything combustible in the room almost all at once.
How does that happen?
As the initial fire burns, it radiates heat. That heat warms up all the other surfaces in the room, furniture, other walls. The ceiling finish itself until they reach their ignition temperature. Flashover is when they all ignite very rapidly, almost simultaneously.
Sounds catastrophic for anyone inside.
It is. Escape time drops essentially to 0. The NFPA 286 test criteria, especially related to flame spread and heat release, are designed to ensure the finished material doesn't contribute enough energy or spread flames fast enough to cause flashover within a typical time frame needed for escape or for firefighters to intervene.
And that ties into point 4, the 300 kilowatt of peak heat release limit. Why 300 kilowatts?
That number is a critical threshold. If the finish starts releasing heat faster than that, it basically takes over as the main fuel source in the room. It stops being just a surface covering and starts driving the fire itself, making flashover much more likely and much faster. Capping it at 300 kilowatts keeps the finish relatively passive.
And the last one, the 1,000 square meter smoke limit. That's all about visibility for escape, right?
Entirely. Remember, most fire fatalities are from smoke inhalation, not burns. That limit ensures the finish doesn't generate so much smoke that people can't see the exit signs or find their way out or become overcome before they can escape.
So if a material passes all 5 of those NFPA 286 criteria, as mentioned in 803.1.2.
Then it's accepted, period. Regardless of the A, B, or C classification that might otherwise be required by the tables, it's proven its performance in a real-world scenario.
But you said most materials aren't tested this way.
Right. The 286 test is expensive. It's destructive. So most materials rely on the alternative. ASTM E84, or the very similar UL 723. That's the Steiner tunnel test.
And that's where we get the Class A, B, and C ratings, based on Flame Spread Index, FSI, and Smoke Developed Index, SDI.
Exactly. The E84 test puts a sample in a tunnel and measures how quickly flame spreads along its surface. That gives you the FSI. Class A is the best. FSI of 0 to 25. Think concrete, gypsum board.
Yay.
Class B is moderate. FSI 26 to 75. Maybe some fire retardant treated wood paneling falls here.
Right.
And Class C is the lowest performance generally allowed for interior finishes.
Yeah.
FSI 76 to 200.
And what about the smoke? The SDI, all 3 classes have the same limit, 450. Why 450?
That 450 SDI limit is another critical life safety benchmark. Fire research links an SDI around 450 to the point where smoke becomes so thick the visibility is severely limited. You basically can't see your way out.
So even if it doesn't spread flame fast?
If it pumps out tons of smoke, it's still incredibly dangerous. It fails the classification if the SDI is over 450, no matter how low the FSI is.
Got it. Now, Section 803 also gets into specific material types and installation details.
Yes, because how a material is installed matters just as much as the material itself. For instance, 803.2 gives an exemption for really thin materials, less than 0.036 inches.
Like a thin wallpaper or vinyl film?
Exactly. If it's applied directly to a non-combustible surface like gypsum board or concrete, it's generally exempt from the standard testing. The thinking is there's just not enough fuel there, and with no air gap behind it, it won't significantly contribute to the fire.
That highlights the danger of air gaps, doesn't it?
It really does. We'll see that come up again. Then you have 803.3, which deals with heavy timber construction, like in Type 4 buildings.
Those big solid wood beams and columns.
Right. Heavy timber has inherent fire resistance because it chars slowly instead of igniting quickly. So the code generally accepts exposed heavy timber elements without needing a specific A, B, or C classification.
But there's a big exception, right?
A huge one. That acceptance goes out the window if the heavy timber is in a critical egress path, like an exit stairway, an exit ramp, or an exit passageway.
Why the restriction there?
Because any fire spread in those areas could trap everyone trying to get out. So in those specific locations, even heavy timber has to meet the required Class A, B, or C rating determined by the occupancy and other factors. No compromises in the exit path.
What about systems where you have multiple layers, like fabric stretched over a frame or textile wall coverings?
Yeah, sections like 803.5 for textiles, 803.7 for expanded vinyl, and 803.1 for site-fabricated stretch systems all share a common principle.
Which is?
You have to test the entire assembly as it's going to be installed, not just the fabric on its own.
So for a stretch system, that means the fabric, the frame it's stretched on, and how it's mounted.
Exactly.
Yeah.
If the frame is wood, or there's a combustible adhesive, or if there's an air gap behind it, all of that changes how the fabric performs in a fire. The code demands the test reflects the final installed condition.
That's a really critical point for designers and installers. The installation method is part of the code compliance.
Absolutely. You could take a Class A fabric, install it improperly with a flammable adhesive and an air gap, and suddenly you might have a Class C hazard, or worse.
Okay, this is a good point to transition to maybe the most used part of this chapter, especially for exams.
Well,
Table 803.13.
Yes, Table 803.13. Interior wall and ceiling finish requirements by occupancy. This table is your command center for Section 803.
It brings everything together.
It does. It takes the occupancy group, the specific location within the building, like is it an exit, a corridor, or a room, and whether or not the building has sprinklers, and it tells you the required finish class. A, B, or C. If you master this table, you can answer a huge chunk of Chapter 8 questions.
Let's walk through an example. Say we have a building with a hotel, Group R1, maybe a restaurant, Group A2, and some office space, Group B. How do we use the table?
Okay, let's start with the highest hazard there, the A2 restaurant. And let's assume, just for contrast, it's not sprinklered.
Okay, non-sprinklered A2.
Looking at the table. In the exit stairways and ramps. Class A required. Highest standard.
Yes.
Makes sense. Lots of people may be unfamiliar with the layout.
Right. Corridors.
Corridors and other exit access ways also need Class A and a non-sprinklered A2. But inside the main dining room or assembly space itself, the requirement drops to Class B.
Interesting. Why lower in the room itself?
The thinking is the fire might start in the room, but the paths out need the absolute highest level of protection against contributing to fire spread.
Okay. Now compare that to the Group R1 hotel part of the building, also non-sprinklered.
All right, R1. Again, transient occupants, sleeping risk. In the non-sprinklered column, exit enclosures still need Class A. Corridors drop to Class B. And inside the individual hotel rooms, Class C is permitted.
So we see the requirements easing up as you get further from the main exit path.
Generally, yes. Now let's look at the Group B office space. Lower hazard, generally.
Still non-sprinklered for this example.
Okay, Group B, non-sprinklered. Exit enclosures still demand Class A. But look, corridors and rooms only require Class C.
Much more lenient.
Right. The code assumes occupants are awake, alert, familiar with the space, fewer people relative to the area compared to assembly.
But now let's flip the switch. What happens when we add sprinklers? That's the other major column in the table.
Sprinklers are the game changer in this table, and often throughout the code. Let's go back to that A2 restaurant. If it is sprinklered, the requirement inside the main room drops from Class B down to Class C. That's a direct trade-off the code offers. Put in active fire suppression, sprinklers, and you get more flexibility in your passive finish choices.
But that flexibility has limits, especially in really high-risk places, right? This brings us to things like hospitals, Group I2, and those critical footnotes in the table.
Excellent point. Let's look at footnote E. It applies to Group I2, hospitals, nursing homes. It says the interior finish in corridors has to be Class A, and in rooms it has to be Class B or better. And importantly, this applies even if the building is fully sprinklered.
Wait, so the sprinkler trade-off doesn't apply there? Why not? That seems inconsistent with the general rule.
It does seem inconsistent at first glance. But think about the occupants in an I2 facility. Many might be non-ambulatory, bedridden, needing assistance to evacuate.
So the sprinklers control the fire, but they don't help the patients get out faster.
Precisely. The evacuation time is inherently much longer and more complex. So the code takes an extra layer of precaution. It demands a higher baseline for the finish materials, Class A in corridors, B in rooms, to ensure the finishes themselves contribute almost nothing to fire spread during that extended evacuation period. The risk profile of the occupants overrides the typical sprinkler credit in this specific case.
That makes sense. The system has multiple layers of safety. What about footnote C? That one seems important too, dealing with rooms.
Footnote C clarifies that the rooms category applies to most spaces that aren't specifically corridors or exits, but it also contains that common sprinkler trade-off we talked about.
How does that work?
It says if a room is protected by sprinklers, the required finish class for that room can usually be reduced by one level, say, from B to C, or from C. Well, it can't go lower than C. Class C is the minimum.
So if a non-sprinklered hotel room, R1, needs Class C anyway, sprinklers don't change that specific requirement.
Correct. But if, say, a different occupancy required Class B in a non-sprinklered room, adding sprinklers would allow you to use Class C instead. It's the code's main incentive for sprinklering those individual spaces.
Okay, one last piece in Section 803, Section 803.15, applying finishes over fire resistance rated construction. This connects back to Chapter 7, right?
Directly. If you have, say, a wall that needs to be rated for 2 hours according to Chapter 7, you can't just slap any finish on it in a way that compromises that rating.
Yeah.
Especially if you create voids or gaps.
803.15.1 covers direct attachment, basically. Stick the finish right on the rated wall. Seems simple.
Usually is. Just make sure the finish meets its own Class ABC requirements. The real complexity comes in 803.15.2, which deals with set-out construction.
What does that mean?
It's when the finish is installed with a gap behind it, specifically more than 1 3/4 inches away from the fire-rated backing. Think maybe paneling installed on furring strips.
Why is that gap size, 1 3/4 inches, the trigger point?
That gap size is considered large enough to create a potential concealed combustible space. The big worry is creating what's sometimes called a chimney effect.
Meaning fire can race up inside the wall.
Exactly. A hidden void, especially a vertical one, can let fire and smoke spread rapidly behind the finish, bypassing the fire rating of the main wall assembly. It could jump between floors or compromise fire blocking. It's a serious hazard, regardless of the finished material's surface rating.
So if you create that gap, the code clamps down hard.
It does. Generally, if you have that set-out condition, the interior finish itself usually needs to be Class A or B, unless you meet one of the exceptions.
And the exceptions are?
Exception 1 is the big one. If the space is protected by automatic sprinklers, the set-out rule is typically waived. The sprinklers are expected to control the fire before it gets established in the void.
Makes sense. Active protection offsets the passive risk.
Exception 2 involves using furring strips, but only if that concealed space is properly fire blocked according to Section 718. So the mitigation is either active suppression, sprinklers, or passive compartmentalization, fire blocking.
What about the things holding the finish up, like in a suspended ceiling? That's 803.15.3.
Right. If that ceiling is part of a fire resistance rated assembly, the hangers and grid members generally have to be non-combustible or rated themselves. The ceiling tile rating doesn't matter if the grid holding it collapses in the heat.
But there's an exception for certain construction types.
Yes, specifically in Type 1 and Type 4 construction, fire retardant treated wood members might be permitted for support if Chapter 7 allows it for that specific assembly. It's another link between material type, finish, and the overall structural fire strategy.
And finally, what about basic wood trim, like baseboards or crown molding? They're usually wood, which is combustible.
They get a limited allowance under 803.15.4. The total area of combustible trim can't exceed 1/12. That's about 8.3% of the wall or ceiling area it's attached to.
Why the limit?
To ensure that even though trim is often Class C or maybe even unrated, it doesn't add up to become a significant fuel load that could compromise the fire performance of the larger wall or ceiling. And if the trim is thicker than ½ an inch, there's some additional rules too.
Okay, let's shift gears now to Session 804, Interior Floor Finish. We're moving from walls and ceilings down to the floor, carpets, vinyl, wood, tile, etc.
Right, and this is about managing fire spread horizontally along the floor, especially in exit paths. It requires a different test method than walls and ceilings.
Not the Steiner tunnel test.
No. For floors, the standard tests are NFPA 253 or ASTM E648. These use what's called a critical radiant flux, or CRF test.
Why CRF instead of the flame spread index, FSI?
It simulates a different fire condition relevant to floors. Think about a room nearing flashover. The hottest part is the layer of smoke and hot gases banked up near the ceiling. That layer radiates intense heat downwards onto the floor.
Okay.
The CRF test mimics this. It uses a radiant heat panel positioned above the floor covering sample. It measures the minimum level of that radiant heat energy needed to make the flooring material keep burning.
So it's testing if the floor will ignite and spread flames under heat from above?
Exactly. Specifically simulating conditions someone might encounter crawling along an escape route beneath that hot smoke layer. Will the floor itself start burning and block their path?
And like wall finishes, floor finishes get classified based on this test?
Yes, but only into two classes for floors. Class 1 floor finishes need a higher CRS, not less than 0.45 watts per square centimeter.
Meaning they resist ignition better under heat.
Correct. They require more radiant energy to keep burning. Class 2 floor finishes have a lower requirement, a CRF not less than 0.22 watts per square centimeter.
So Class 1 is significantly safer, especially for critical escape routes.
Definitely. And Section 804.3 emphasizes that these products have to be clearly identified with a label or tag showing their classification. You need to know what you're installing.
Now, 804.4.2 talks about minimum critical radiant flux. It seems to target specific high-risk areas.
It does. The code says that in all occupancies, when you're putting flooring in exit enclosures, corridors, or ramps that serve certain high-risk groups, you have to perform a calculation.
A calculation?
Yes. There's a specific calculation required to ensure the flooring meets the minimum CRF needed for that specific location and occupancy risk. We won't go into the math here, but it's crucial to know that compliance isn't just about picking Class 1 or 2. It involves this calculation in those key egress zones.
And which occupancy groups trigger this tougher requirement?
Pay close attention here. It applies in those egress paths serving Group I1, I2, I4 that's institutional, like assisted living, hospitals, daycare, also Group M for mercantile, and Groups R1 and R2 hotels and multifamily residential, and even Group S for storage, where the contents might pose a high hazard.
So places where evacuation might be slower, more crowded, or complicated.
Exactly. The code wants to ensure the floor doesn't contribute to trapping people in the corridors or stairwells.
And predictably, is there a sprinkler exception here?
There is, a big one, again, in 804.4.2. If the building is equipped throughout with an automatic sprinkler system, those specific minimum CRF requirements for corridors, exit enclosures, and ramps are generally waived.
Wow, that seems like a major incentive to sprinkler a building if you want flexibility in floor coverings.
It absolutely is. The sprinklers are seen as providing enough protection against significant fire spread along the floor in those egress paths. But remember, The flooring still has to meet the basic cell of class lines. Class 1 or 2 requirements appropriate for the area. Sprinklers mainly waive that extra calculation and potentially allow Class 2, where Class 1 might otherwise have been mandated by the calculation. You still need a rated floor finish.
Okay, let's move to Section 805. This one deals with combustible materials in Type 1 and Type 2 construction. This sounds like managing a contradiction.
It kind of is. Type 1 and Type 2 construction are required, by definition in Chapter 6, to be built primarily of non-combustible materials like steel and concrete to achieve high fire resistance ratings.
Right, they're designed not to burn easily.
But in reality, you need some combustible materials inside, even in those buildings. You need wood blocking to attach drywall, maybe wood sleepers to install certain types of flooring. Section 805 acknowledges this reality.
So it allows small amounts of combustibles, but under strict controls.
Precisely. The goal is to allow these necessary minor uses without compromising the fundamental non-combustible nature and fire strategy of the Type 1 or 2 building.
So 805.1.1 covers sleepers, bucks, blocking the stuff hidden in walls or floors?
Yes. These pieces have to be limited in size, but more importantly, any concealed spaces they create must be fire blocked according to Section 718. Fire blocking is mandatory.
Remind us how fire blocking works in this context.
If you put wood sleepers on a concrete floor to nail hardwood to, you create small channels or voids under the floor. Fire blocking means installing tight-fitting pieces of wood or approved non-combustible material across those channels at regular intervals, like at walls, to prevent fire from racing unseen through those voids. It compartmentalizes the small combustible element.
Got it. Preventing hidden fire spread. What about wood-finished flooring itself, like hardwood floors? We see those in high-rises.
Section 805.1.2 permits wood finish flooring, but only if it's applied directly to the non-combustible slab, like concrete, or attached to those wood sleepers that are embedded in the concrete or properly fire blocked. Again, the key is preventing a continuous unblocked air gap underneath that could spread fire across the floor plate.
And 805.1.3 puts limits on insulating boards used in these construction types.
Right, because insulation can sometimes add significant fuel load. If combustible insulating boards are used, maybe for sound, they're usually limited in thickness, maybe half an inch in size, perhaps 4 feet square. And crucially, they have to be attached directly to the non-combustible floor or roof structure, no creating extra fuel layers or concealed spaces.
So the theme here is allowing necessary combustibles, but meticulously controlling their size, location, and ensuring any voids they create are fire blocked.
Exactly. It's micromanaging the combustibles to maintain the integrity of the non-combustible construction type. Very practical rules.
Okay, on to Section 806, decorative materials and trim. This feels different again, things like curtains, tapestries, banners, maybe even large amounts of artwork.
Yeah, this stuff is often temporary, easily changed, but can represent a huge potential fuel load, often concentrated in one area. That's why Section 806.1 starts with 4 basic rules that apply everywhere, no matter the occupancy.
What are those 4 ground rules?
1. Nothing explosive or highly flammable. Seems obvious, but it has to be said. 2. Combustible decorative materials usually need to be fire retardant treated, and critically, that treatment needs to be maintained. It can't wash out or wear off. This is big for ongoing compliance.
Okay.
3. Decorative materials can't obstruct exits, access to exits, or any part of the egress path. Can't hang curtains over an exit door.
Right.
And 4. There needs to be separation and limitations on how much combustible decoration you have versus non-combustible.
The really tricky part seems to be 806.2, which puts actual percentage limits on how much combustible decoration you can have. This is the code actively managing that fuel load you mentioned.
It is, and the limits can be quite strict, especially in public places. For most assembly, Group A, Educational E, Institutional I, Mercantile M, Hotels R1, and common areas of apartments condos R2, the amount of combustible decorative material attached to walls or ceilings is limited to just 10% of the area of that specific wall or ceiling.
Only 10%? That seems really low for, say, a theater lobby or a restaurant that wants elaborate decor.
It reflects the higher risk. Lots of people, maybe unfamiliar with the space, needing clear egress. But the code does relax this in certain situations.
Where?
The big one is inside individual dwelling units or sleeping units in Group R2. So inside apartments, condo units, or student dorm rooms. There, the limit jumps up to 50% of the wall or ceiling area.
Wow. 10% in a hotel room R1, but 50% in a dorm room R2. Why such a big difference?
It comes down to occupant familiarity and control. In your own apartment or dorm room, you know the layout, you know the exits, and you're usually the one putting up the decorations. The code assumes you'll likely detect a fire sooner and know how to react better than a transient guest in a hotel. That familiarity provides a safety factor, allowing more personalization.
That makes sense. Is there a limit if things are hung from the ceiling, not attached to the wall, like banners?
Yes, there's an overriding limit. The total amount of combustible decorative material suspended from the ceiling or walls can't exceed 10% of the floor area of that room or space.
Ah, so you can't just hang massive amounts of fabric from the ceiling to get around the wall percentage limit.
Exactly. It closes that potential loophole.
What about testing requirements for these decorative fabrics? That's in 806.4.
Right. Decorative fabrics and films generally have to pass NFPA 701. That's a standard test specifically for how flame propagates on textiles and films, very relevant for curtains and drapes.
And there's a heat release limit, too.
Yes, a maximum heat release rate of 100 kilowatts when tested, according to NFPA 289.
100 kilowatts. That's way lower than the 300 kilowatt limit we saw for wall finishes back in Section 803. Why so much stricter for decorations?
Because decorative materials, fabrics, films, are often very lightweight, have a lot of surface area for their weight, and are frequently hung with air circulating behind them. This makes them ignite very easily and spread fire very quickly.
So they could cause problems much faster.
Potentially, yes. The code demands that even the limited amount of decoration allowed, that 10% or 50%, must not contribute significantly to the fire's intensity. If they were allowed to release 300 kilowatts, they could potentially trigger flashover almost instantly because they get involved so fast. The 100 kilowatt limit keeps them much more passive.
What about trim used decoratively, like wood picture rails? That's 806.7.
It basically says that trim used as decoration still has to meet the requirements back in Section 803, meaning it generally needs to be Class C or better. And it also has to comply with the area limitations for trim we discussed earlier, the 112 to 8.3% rule.
And 806.6 has a specific note about lockers.
Yeah, if you have lockers made of combustible materials, like wood or plastic, located in corridors, they get treated as interior finish. They typically have to meet the Class A or B requirements for corridors from Table 803.13. There's a slight modification if they're mostly wood with non-combustible frames, potentially allowing Class C. The point is to prevent rows of lockers from becoming a massive line of fuel in a critical exit path.
Okay, let's wrap up Chapter 8 by looking quickly at the last two sections. 807 on insulation and 808 on acoustical ceilings. These seem more like pointers to other places.
Largely, yes. Section 807 is very direct. It just says thermal and acoustical insulation needs to comply with Section 720.
So Chapter 8 deals with the surface spread, but Chapter 7, specifically Section 720, deals with the insulation's inherent fire properties, like staying in place, not contributing fuel within concealed spaces, needing fire blocking, that sort of thing.
Exactly. Chapter 8 sends you there for the detailed insulation requirements.
And Section 808, acoustical ceiling systems. These are everywhere in commercial buildings, big surface area.
Very common. The main rule is in 808.1.1. The acoustical materials themselves, the tiles or panels, have to meet the interior finish requirements of Section 803.
Meaning they need a Class A, B, or C rating based on the Steiner tunnel test, ASTM E84.
Correct. Based on their flame spread index and smoke developed index, just like a wall finish. You check Table 803.13 for the required class based on occupancy, location, and sprinklers.
And the installation matters here too, especially for suspended ceiling.
Absolutely. 808.1.111 requires suspended ceilings to be installed following specific ASTM standards C635 and C636. These cover the metal grid system, the T-bars, and how it's erected.
Why regulate the grid?
Because even a class of ceiling tile is useless if the grid holding it up fails early in a fire, collapses, and dumps burning debris onto people trying to escape, or just blocks the path entirely. The support system has to be robust.
And finally, 808.1.1.2 links back to Chapter 7 again.
Yes. If that acoustical ceiling is actually part of a fire resistance rated assembly, maybe it's the membrane protecting steel beams above, or part of a rated corridor ceiling, then the entire system has to comply with the requirements of Chapter 7 and be installed exactly as it was tested for that rating.
It really all ties together. Chapter 8 for the surface spread, Chapter 7 for the endurance and assembly rating.
You can't really understand one without considering the other. They work as a system to provide life safety.
Okay, we have covered a lot of ground in IBC Chapter 8. If someone's studying for an exam or working on a project, what are the absolute key takeaways they need to remember?
Well, I think the main thing is that Chapter 8 is fundamentally about buying time, managing the initial fuel load to slow down fire growth and smoke spread so people can get out.
And the way to navigate it.
3 key questions, always. 1, what's the occupancy group? 2, where are we in the building, exit, corridor, or room? 3, is it sprinkled or not?
Those three factors are the keys to using Table 803 on 1.3 for wall and ceiling finish classes, A, B, or C.
Exactly. And remember, for floors, it's a different test. Critical radiant flux, or CRF, focused on resisting ignition from heat radiating downwards, especially in escape roads. Class 1 is better than Class 2.
It's all about managing risk based on how the building is used and where the finishes are located.
Precisely. It's a system.
All right, here's a final thought for you, our listeners, to chew on. We saw again and again how having an automatic sprinkler system created major exceptions or allowed less stringent requirements. Think about 803.15 allowing set-out construction, or 804.4.2 waiving the tough CRF calculations for floors.
Yeah, that reliance on sprinklers is woven throughout the chapter, and really throughout the whole code. It's like the IBC offers this consistent trade-off. Invest in an active fire protection system, like sprinklers, and you often gain more flexibility with the passive fire resistance elements, like the finished materials.
It's a core principle, isn't it? Active systems balancing passive constraints. It reflects that shift towards performance-based thinking and fire safety.
It really does. It shows how the code uses different strategies working together to achieve the required level of safety.
A really interesting way to see how the pieces fit.
Definitely something to keep in mind as you navigate other chapters, too.
Well, thank you for joining us on this exploration of IBC Chapter 8 here on the Code Navigators. If this discussion was helpful for your studies or your professional work, please consider supporting the show. You can find the link to our Patreon in the show description.
Your support helps us continue breaking down these complex code requirements. We really appreciate you tuning in and trusting us as your guides. Until next time, keep navigating those codes.